Hey Calculus, here we go, Distance Learning 2.0. Today we are going to learn how to find a limit on a graph using a table and algebraically. So right up, we're going to find a limit using a graph. Okay, so we have this equation right here. X cubed minus 7x squared plus 17x minus 15 divided by x minus 3. The first thing we're going to do is we're going to go to y equals and we're going to enter it into our calculator. Make sure that you have parentheses around the top and the bottom. I would change your window to this, putting your x-axis from 0 to 5 and putting your y-axis from 0 to 5. Then you can see it. So here is a picture of the graph. All right, number 2. If we substitute 3 in for x into the equation, what form does the answer take? Well, if I plug in a 3 on top, that is going to give me a 0. And if I plug in a 3 on the bottom, that's pretty obvious. 3 minus 3 is 0. So that gives us 0 over 0. That is the form. The name given to that form, 0 over 0, is called an indeterminate form, and that's pretty important when it comes to limits. All right, if you have 0 over 0, that tells you that there probably is a limit there. All right, number 3, the graph has a removable discontinuity at x is equal to 3. All right, this right here, you guys, is just a fancy name for a hole. Okay, that's just a fancy name for a hole. All right, now let's find the limit. When we're looking for a limit using a graph, what we want to do is, I like to put a vertical line through what number x is approaching. So here is x is equal to 1, 2, 3. So I'm going to put a vertical line, imaginary vertical line, through x is equal to 3. All right, now I can trace my graph. Coming towards that vertical line from the left, if I trace the graph, it's coming in at a y value of 2. All right? And if I trace my graph towards this vertical line, if I trace the graph coming towards that vertical line, I'm coming in at 2. So my left limit is 2, my right limit is 2, so my limit as x approaches 3 is 2. Okay, so the easiest way that I can tell you to pick out a limit from a graph is put in an imaginary vertical line through whatever you're approaching and trace the graph towards that vertical line from the left and from the right. Okay, let's tackle how to find a limit using a table. You're going to go right up to here. You're going to hit second window. We're going to start our table at 3. That's what we're approaching. And we're going to go in smaller increments. Delta stands for change in. So this is increments of 0.1. So it's going to look like this. Okay, do that right now. And pause the video and check to make sure that your y values are the same as what I have here. Okay, so now here we are coming in closer and closer to 3 from both sides. Coming from the left towards 3, coming from the right towards 3. My y values are getting closer and closer to, it looks like 2. All right, if you want to even get a better answer using a table, then we're going to go into smaller increments. Over here, you can see we're going in increments of 0.01. So you would just change this right up here to 0.01. Okay, take a minute and do that on your own and make sure that your y values are the same as what I have on this table. So you can see, here is x is equal to 3. As we get closer, as our x's get closer and closer to 3 on the left, and on the right, my y values are getting closer and closer to 2. All right, so right here, using this table, the limit as x approaches 3 of this big function here is 2. All right? Okay, so we've covered how to find a limit using a graph, and how to find a limit using a table, how to set up our table. Now we're going to find a limit algebraically. These right here are the steps. Number 1, can you do direct substitution? Can you directly plug in what x is approaching? The only time you can't is if it causes you to divide by 0. Right here, if I plug 3 in here, I'm dividing by 0. So this example, we can't do direct substitution. But if it doesn't cause you to divide by 0, then you can just plug in this value. If you can't do direct substitution, then you have to check for the indeterminate form, 0 over 0. If you have that, that's step number 3. If you have an indeterminate form, there probably is a limit there. That is your clue to factor and cancel so that you can do direct substitution. Okay, so we're going to do this example right here. We have a limit problem. Anytime you see a limit problem, the first thing you ask yourself is, can I do direct substitution? Can I plug this 3 in for x here, 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 and here? Well, I can't, because if I plug in 3 right here, I have 3 minus 3. I'm dividing by 0. So I can't do direct substitution. Now, we already checked this example. I not only have I not only have 0 on the bottom, I have 0 on the top. So that is my clue. This tells me there probably is a limit, so my job is to factor and cancel so that I can do direct substitution. Because this is a cubic, I can use synthetic division to factor that. So let's try it. So if you remember to set up our synthetic division, I'm going to go up here. Okay, I put my leading coefficients in that top row. So I have 1x cubed. I have negative 7x squared. I have 17x. And I have negative 15. Now, whatever makes the denominator go to 0 goes out here. So my 3 has to go right here. Again, whatever makes your denominator go to 0, I set that equal to 0. X minus 3 is equal to 0. X is equal to 3. That goes up here. That's how you set up your synthetic division. Okay. Now we go to work. We bring down the 1 and we multiply 1 times 3 and we put it right here and get 3. Then we add negative 7 and 3 gives us negative 4. Now we multiply negative 4 times 3 gives us negative 12. Then we add 17 and negative 12 gives us 5. And finally, one more time, we multiply 5 times 3 and we get positive 15. And then when we add the column, we do get a 0. All right, so now we can rewrite our numerator. Okay? The denominator stays the same. Now, here's the important part. The numerator not only includes this right here, but you have to include this right here. Now this, you guys, is the root. But we need the factor. If the root is 3, the factor is x minus 3. That's what has to go right in your numerator. So I don't need the root, I need the factor. All right, so let me get that so you can read it. I'm going to highlight it in red, what has to be part of your answer. So we're going to factor this numerator into this times this. So we need x minus 3 times 1x squared minus 4x, and then finally plus 5. Okay, now this is equivalent to this. This numerator is just factored. So don't forget, when you read your synthetic division, you need this, get its factor, times this. All right, now this is nice because now these are going to cancel. All right, so now I have the limit as x approaches 3 of what's left. This is what's left, x squared minus 4x plus 5. Now I can do direct substitution. All right, so now I do direct substitution. Okay, so I get 3 squared minus 4 times 3 plus 5. So that gives me 9 minus 12 plus 5, which gives me exactly what I need to have 2. Okay, so that is how you find a limit algebraically. Okay, please try this example on your own and check the solutions to see if you get it correct. All right, thanks, calculus. Keep in touch. Please shoot me an email or a text if you need any help. So finish this example on your own and then head to the homework worksheet. All right, bye, calculus.